All right, hello everyone, and welcome back to Calculus. So this is our 11th video, and it's about graphing derivatives. So now that we know that derivatives are a function, we should be able to draw their graphs. So really, when I say draw their graphs, it's going to be a little bit less formal than that. Really, we're just going to kind of sketch the graphs today. So it should be clear that we're not being super rigorous in this lesson. Okay. So my first question to you is, do you remember how derivatives are defined visually? Hopefully you do. The idea is that the derivative of a function at a point is the slope of its tangent line. In other words, if I wanted to find g prime of 4, I need to look at the graph of g of x, go look at x equals 4, draw the tangent line there, and then find the slope of that line. That number is g prime of 4. So we're going to sort of use this process over and over again to be able to sort of overall get the sketch of g prime of x. Okay, so for example, if I let this function be f of x and I want to sketch the graph of f prime of x, then what I'm going to do is I'm probably going to just choose a bunch of test points. Let's say x equals 1. If I draw the tangent line, that tangent line is this. Okay. So the slope of that line looks like it is 1. Perfect. So at x equals 1, it looks like I have a slope of 1. So over here, what I'm graphing is x versus f prime of x. So I'm graphing the slopes of things. Okay, what about at x equals 2? If I instead look at x equals 2, and I look at my graph, and then I draw the tangent line. Oh, it looks like I've drawn the same tangent line. So the slope is still going to be 1. So at 2, slope of the tangent line is 1. And so forth. And if I keep doing that over and over again, no matter what point that I choose over here, it turns out that you're going to draw this same tangent line. And so your slope is going to be 1. So in my graph of f prime, that every x value above 0, it seems like my slopes of my tangent lines are all 1. Then if we do that same sort of process, and I try to draw all my slopes or all my tangent lines on the other side of this sort of corner, then let's see, for example, at -1, if I draw my tangent line, I'm going to get a tangent line that has a slope of 0. So -1, my slope should be 0. At -2, same tangent line, my slope will be 0, and so forth. And so if I sort of look through and I combine all of those, it looks like everywhere below 0, I'm getting a slope of my tangent line to be 0. So f prime of x looks like it is a piecewise function, and it is piecewise constant, in fact. It's worth noting, remember that we don't have derivatives at these corner points. So for example, here, f prime is not defined, and that's because when we look at the definition of f prime, it's a limit. And so you need the slopes on the left and the right to be consistent. You need the left limit and the right limit to exist and match. And right now, our left limit, and our right limit are not going to match up. So our function f prime of x should not exist at x equals 0. And that's fine. In our picture, we have not said that f prime of 0 is anything because we have open circles. Okay, So that one was pretty straightforward because thankfully all of our tangent lines were actually just lines with one of those two lines. So let's go to maybe a bit more complicated of a picture. So if I want to find if this is the graph of f of x, and I want to sketch f prime of x, now we really are going to have to be sketching more so than directly computing and finding clear pictures. Let's see. So if I think about it and I try to think about drawing a bunch of my tangent lines, if I think about like my tangent line here, I'm going to have something with negative slope and like decently high slope. Then I'm going to get more and more towards like, this still has negative slope, but a bit less intense. This has negative slope, but even less sloped, and so forth. And then, so what that means is to the left of 0, if I look at my x's, my slopes of my tangent lines are all negative. They start out really negative and they get smaller and smaller negatives. So I'm just going to sketch maybe something like this. Because again, I'm sketching x versus f prime of x. So this would say for like this x value, the slope is negative and it's more negative than at say this x value here. So sort of that's that side of the graph. And then at x equals 0, my tangent line should have a slope of 0. So my graph should go through 0, 0, because at 0, the slope of the tangent line is 0. And then for x values above 0, again, I'm going to think about drawing a bunch of the tangent lines. And if I look at these, for x's above 0, they're all going to have positive slopes. But they're going to start out having sort of more shallow positive slopes, and then they're going to get more and more intensely positive. And so maybe the graph looks something like this on the other side. So my slopes, which again correspond to my y values, are going to start out as sort of small y values or small slopes, small positive slopes, and then they're going to get to bigger and bigger y values. So again, this is very much just estimating. This is what I drew based on that pattern. It would have been totally valid to draw other things such as, so let's see. This is another graph that starts out super negative, gets less and less negative. At 0, it's 0, and then starts out a little bit positive and gets more and more positive over time, and so forth. So there were lots of things that you could draw thinking about that pattern. But as long as you drew something sort of with that pattern and thought about as many derivatives as you could, your sketch is fine. Okay, so with that, go ahead and try sketching the graph of f prime of x if this is f of x. Pause here and try to sketch the graph of this, of f prime. All right, I'm assuming you're back and you've paused. So the actual graph of f prime should look something like this. So the points you should definitely have is like there should be your slopes of your tangent line should be 0 at each of these points. And then you should have had sort of the general pattern of it was increasing, or f prime is increasing for some period of time and then decreasing. And it gets really negative and then it comes back up to 0. Something vaguely shaped like that is a good enough sketch. And then I claim this is the full actual definition, or full actual derivative, if you're a bit more careful with it. All right, wonderful. Thanks, y'all.